would meet. But you see, once they are all going up, short up, they will only meet when one has gotten to the maximum height and it is returning. So because P was short earlier, P would go, and after 4 seconds, Q would also go up. But they will only meet when Q has gotten to the maximum height and it is returning. That's the point where they will meet. This is the point they are meeting or crossing. Okay. But it will do so when P has gotten to the maximum height and is returning. Au revoir. Au revoir, or it was a mistake.
Yes, please.
Okay. So before the two particles meet, or the two bodies P and Q, they are initially shot from the same height. So this is P. This is Q. P was shot earlier. And after 4 seconds, with initial velocity of 40. After 4 seconds, Q was also shot to go up. But when would they meet? They will only meet after P has gotten to the maximum height and is returning. So when P has gotten to the maximum height from the point where he was thrown to the point where the final velocity is 0. When it is returning, okay, that is when P can possibly meet Q. So we are assuming that this is the level where the two particles meet, P and Q. So the height, the vertical height where Q meets, P, let's assume that is equal to small letter h. So let the point where the two particles meet be equal to small letter h. From the ground, or from the point where they were initially thrown. Let the point where they meet be equal to h. Okay, so the first question demands that we find this h. Please, are you okay? Are you okay with the diagram?
Please come again.
The question is saying that two particles P and Q were projected from the same height. So they were initially thrown from the same height. Okay, so this is particle P, particle Q. They were all shot vertically up. Particle P is first up with a velocity of 40 meters per second. So particle P was initially thrown up with a velocity of this. After 4 seconds, particle Q is shot. So when P was shot, after 4 seconds, Q was also shot to go up. Okay, now what it means is that in terms of time, P leads Q by 4 seconds because P was shot and 4 seconds later Q was also shot. So in terms of time, P leads Q by 4 seconds. Are you okay with that part, that statement? Are we okay? Now what I'm saying is that the two particles can only meet when P has gotten to the maximum height and is returning. I'm coming. Let me answer some of you. Said that the link is invalid. The same old link is now invalid. Or did you also encounter such problem when you were joining? Okay, so in terms of time, P leads Q by 4 seconds. So if P's time is t seconds, what will be Q's time? If P is t seconds, what will be Q? Yes, anybody? If P is t seconds, what will be Q? Oh, who is talking? P leads Q by 4 seconds. Okay, so Q would be t minus 4. Because in terms of time, P leads Q by 4 seconds. All right. So they can only cross, that P and Q would only cross when Q has gotten to the maximum height and it is returning. Okay. So we are saying that let the point or the height where P, Leslie, mute yourself. Let the point where P and Q cross each other be H. Okay. Let the height H represent the point where they will cross each other. Okay, so if this is it, how do we find this H? First, let's find the maximum height reached by P. Maximum height reached by P. Yes, how do we determine the maximum height reached by P? Somebody to quickly help me. The maximum height reached by P.
Sir, sir,
The
we
maximum
should use
height.
the formula S is equals to UT plus half GT squared.
But there's a
by
standard
P.
formula. No, there's a standard formula. The maximum height reached by P when a body is going vertically upwards. Okay, so let's use the standard formula, okay, to calculate for the maximum height reached by P. Yes?
U squared over 2G.
So U squared over 2G would help us here. So this is equal to the initial velocity of P is 40. So 40 squared over 2 times 10. And this will be equal to, I think, 800. 40 times 40 over 20. So 800. Or 80. It's 80 rather. So this is equal to 80 meters. That's the maximum height particle P could reach. Now let's also determine the time taken to reach the maximum height. Time taken by P to reach the maximum height. And that can also be determined using U over G. Initial velocity 40 divided by gravity 10, meaning it will take P 4 seconds to reach the maximum height. Okay, so this height from the ground to the maximum height we've determined as 80 meters. Okay, now if from wherever it was thrown, to the maximum height is 80. From here to here is 80. And when P gets to the maximum height and it is falling, it will be free falling. So when P gets to the maximum height and it is dropping back to maybe the ground, the initial velocity at that point, U is equal to 0. So if U is equal to 0, now the question is saying, if at the point where P and Q meet, the final velocity of P is equal to 15 meters per second. We are told that at the point where P and Q crosses, the final velocity of P is 15 meters per second. Please, are you with me?
Yes, sir.
So if initial velocity is 0, and then at this point where P crosses Q, the velocity is 15, we are to calculate this vertical height. Let's find the vertical height traveled from the maximum height to the point where it crosses Q. I mean this height. This height, Y. We know U to be 0, and the final velocity of P is 15. So let's use that the information given to find the vertical height traveled from the maximum height to this level. Y. Please try it for me.
Is the question again?
We are determining that when P gets to the maximum height, the vertical height it will travel before crossing with Q, which I have labeled as Y, this vertical distance. So for P, because it is free falling, when it is dropping from the maximum height, U is 0. And the question told us that when it is crossing with Q, P's velocity is 15. So let's use initial velocity 0, final velocity 15 to find this vertical height traveled by P. That's the question. Just 2 minutes to think through. So when P drops from the maximum height, P drops freely. It drops freely with an initial velocity U is equal to 0. And we are told that as at the point where it's crossing Q, the final velocity is 15. So if P's initial velocity is 0 and the final velocity is 15, how do we determine the vertical height traveled by P? Gerard, hold on, okay? Let them also contribute as well. Yes, what have you had? Leslie, what did you get for Y? Eurefa, what did you get for Y? Hello? What did you get for Y? That vertical height.
Probably, Charlie, I know we found this 6 months, so Charlie, this message is going out to you all. Yeah, that's my thought.
Yes, Henry. Henry, go ahead. What did you get for Y?
11.25.
Come again.
11.25.
11.25. Okay, let's see. So if P is falling freely from here, and when it gets to the point where it crosses Q, velocity is 15, then using the formula H is equal to UT plus half GT squared, I can find H. And this H is what has been represented by Y.
Stop.
Henry, mute yourself. Now U is 0. So UT goes to 0. So 0 plus half GT squared. Now I can also use this, but it means that if I want to use this, then I must know the time taken by the body to move from the maximum height to this level. So we'll use this later. We can find T and substitute it into it to give us Y. Another way to find this vertical height is when I use V squared is equal to U squared plus 2JH. And here our H is the Y. What's represented by Y? U is 0 and V is 15. So we have 15 squared is equal to 2 times 10 times Y, which we are looking for. Okay. Y therefore is equal to 15 squared is 225 divided by 20. And this must be equal to 11.25 meters. Please, how many of you got this? How many of you had 11.25? Okay. All right. As I said, another way out is to find the time taken for P to move from here and get to this level. Okay. The time taken for P to move from here and get to this level so that we can use equation 1. And we can determine the time using the first equation. V is equal to U plus JT. V is 15. U is 0 plus 10T. Therefore, T is equal to 1.5. 15 divided by 10 seconds. So if it would take T 1.5 seconds to move from here to this point, then using equation 1, you can also find Y to be equal to half times 10 times 1.5 squared. And this will also give us 11.25 meters. So 2 different ways to do the same thing. Now look at something. So if it would take that the distance traveled by P to move from the maximum height and cross Q is 11.25. What do you think will be the height H where the two bodies P and Q will cross? What will be the height H where the two bodies will cross? Yes. Yes, what will be H? If P has to travel 11.25 meters from the maximum height to cross Q, what will be the point where they will cross each other, H, from the ground? Yes. I volunteer to share his or her experience with us. How do we determine H? Elizabeth. Elizabeth, go ahead.
And please, I think we'll subtract the 11.25 from the 18 meters.
Exactly. Exactly. The whole height from the maximum height to the ground is 80. So if this part is 11 point, then H would be equal to 80 minus 11.25. And that will be 50. That will be equal to what?
68.75.
So 68.75 meters. And this is the point where they will cross each other. Okay. Now, if it will take P 1.5 meters, 1.5 meters to move from the maximum height to where it will cross Q, what will be the total distance from the point where P is thrown to where it crosses Q? What will be the total distance there? Yes. If the time taken for P to cross Q is 1.5, what will be the total distance from this point to the point where P crosses Q or meets Q? What will be the total distance? Yes. Oh, we found it. We found it. And that is, we determine the time of flight. The time taken to reach the maximum height by P is equal to 2. We got 4 seconds. So it will take P 4 seconds to move from here to the maximum height. Then it will take P 1.5 seconds to move from here to cross or to meet Q. So the total time taken to move from here to this point will be 4 plus 1.5. Okay. So if P leads Q by 4 seconds, then by the time they cross, Q must travel a distance, a time of 4.5 minus 4. So time taken for Q to meet P. P always leads Q by 4 seconds. Would be 4.5. No, sorry, 5.5. 5.5 minus 4. Because P leads Q by 4 seconds. So the time taken for Q to meet P will be 1.5 seconds. Okay. Now the second question is that calculate the velocity with which Q is short. We are to calculate the velocity with which particle Q is short, meaning the initial velocity of Q. The initial velocity of Q. All right. Now, how do we determine that? We can calculate that using the second equation. H is equal to UT. We are going up, so minus half JT squared. Where H is the any vertical height traveled by Q. U is the initial velocity. T is any time T. J is gravity. Now we have gotten to a point where we said it would take H, a height H, to cross P. And that height we've calculated, we got 68.75. So if Q would cross P at this height, Then we have also determined the time taken for KO to cross P, 1.5 seconds. We could use this to find U. So do that for me. Because we know H, we know T, J is constant. Let's find the value of U, the initial velocity of U. Start work within 2 minutes will do. Let's go through that for about 2 minutes and see what the value of U would be. We are looking for the velocity of projection U of KO. Some of you are reporting network challenge issue. So knowing H, we have T. J is constant. Find the velocity of projection of Q, which is U. Are we true? You have 1 minute. Okay. All right, Gerard, I think your answer is correct. Please let me see the message again. It just went off. Send the message again to check your answer. Okay, time is up. Paulette, Lizzie, what did you make?
Please, I got 38.33 meters.
38.
0.33, yes, please. 0.33.
Okay. Somebody also had 53.33. Yes, about 2 of you. Okay. Let's do it and see which one is right. All right. So if that the height were okay, Peter is also getting 38. Let's see. If the height where they will cross each other is 68.75 and U is what we are looking for. The time where KO crosses P is 1.5. So this times 1.5 seconds minus half by 10 times 1.5 squared. So we have 1.5 u minus, this is 5. What is 5 times 1.5 squared? 5 times 1.5 squared. Hello?
11.25.
So 11 points. Good. Therefore, we have 1.5 u is equal to 68.75 plus 11.25. Sum this up for me. 68.75 plus 11.25. What's the sum?
8.
Mhm. Okay, so you have u. Okay, u equal to 80 divided by 1.5. What is 80 divided by 1.5? 53.33. Meter per second. So the 53.33 people have won the battle. Okay, so this will be the velocity of projection of u. Any question before we start with vectors? All right. No question. So vectors. Do I flip the screen? Do I change the position of the screen? When there is no response, it means yes. Yarat, what's the question?
Oh, sir, I have no question. I was asking someone a question.
I don't get you.
Oh, sir, I don't have a question.
Okay. So vectors. Vectors. Yes, what is a vector quantity? Eva. Eva doesn't like answering questions. Elizabeth, what is a vector quantity?
Please, a vector quantity is a quantity which has a specified direction and magnitude.
So a vector quantity has a specified direction and magnitude. Example. Adam. Okay, Elinam, go ahead.
Velocity.
Velocity 2. Yes, more examples. Aqua Leonard, go ahead.
Displacement.
What? Displacement.
Displacement.
Okay. Yes, more views.
Sir, force.
A force, momentum,
Impulse.
moment. What?
Speed. Speed.
Velocity rather. Speed is scalar.
Okay.
Speed is a scalar quantity. Velocity is a vector quantity. And acceleration is also a vector quantity.
Temperature.
Temperature, sorry. Temperature is a scalar. William, go ahead. Wait. Okay, wait. So please revise your scalar and vector quantities for me, please. Right? Okay, so these are vector quantities. in the physical world, physics, and then mathematics. Yes, Gerard, I get you. In physics and mathematics, anything which is a vector quantity is represented by a bold line, okay, with an arrow either at the middle or at the end. So either we represent a vector this way, or the arrow is at the end. Now, the magnitude of the quantity is the size of this length. So if I begin from this point and then this point, this is the magnitude of that quantity. The magnitude is the amount. The arrow indicates the direction, or the arrow specifies the direction of the body. Okay, so this is how we represent vectors. This is the initial position of the vector quantity. This is the ending. But so if by this representation, we can say that the vector is moving from left to right. Okay, if the vector is moving from north to south, this is how we draw it. There's the magnitude. Then the arrow, whether either it is at the middle or at the end, indicates maybe a force of magnitude, maybe 10 Newton, and its direction is from north to south. So the arrow points it. If the magnitude of the force acts at maybe from the south to the north, we have the arrow changed. So this is how we represent a vector quantity. Okay, a vector representation. A vector representation. All right. Now let's look at when you have a negative vector. A vector A, B is represented by this. So when I'm to draw this, it means the starting point of the vector is a point E. Then the magnitude ends at B. And then the direction is from A to B. So this is the vector AB. If I want to indicate the negative of this, it's all about the same magnitude, but reversing the direction. So the negative of this vector AB is equal to the magnitude from A to B, but the direction is changed. This is equal to minus of AB. So that is how we indicate a negative vector. Now, let's look at what we mean by resultant vector. Resultant vector. I have a body. This is the body. And we have a number of forces acting on this body. F1, F2. I can draw the same thing as the same body, but the forces are acting in this manner. F1, F2. So long as I'm not changing the direction of the vector is the same. I'm not changing the magnitude, neither am I changing the direction. So when a number of forces act on a body, what is the effect produced by the number of forces? And this is what we are calling as the resultant vector. Resultant vector. The resultant means results. Okay, the results. So when we talk about resultant vector, we mean that single vector, the single vector that can produce the same effect. Please, I think somebody hasn't muted. Gerard, you have not muted. So when we talk about resultant vector, it is a single vector which can produce the same effect as a number of, okay, vectors. So a resultant vector is that single vector that can produce an effect which is equal as the combined effect of a number of vectors. So it is similar to what one man can do. Maybe 3 men can do the same, or what 3 ladies can do, 1 lady can do the same thing. So it is the resultant vector is that single vector that can produce an effect which is equal as the combined effect of a number of vectors. So if I have 2 people or 2 forces F1 and F2 exerted on the body, okay, what is that single vector whose effect can be equal to this and this? How do we determine that? We are looking for the resultant of these two. The resultant force. Now, when forces are acting in the same direction, the resultant force is equal to the summation of all the forces. So here, resultant will be equal to sum of all F. So long as they act in one direction, the resultant force will be F1 plus F2. And this is, let's assume you have a car damaged or broken down on the road, and you want to move the car. Because a single person cannot apply a force to overcome the weight, you look for many people. When they come, because you want to push the car from the scene, okay, they will all exert a force on the car in one direction. We can never have a situation where some people will be pushing from the front, others will be pushing from the back. They will all exert the force in one direction. By doing so, they are combining, summing up the forces. So when vector quantities forces are act in one direction, the total or the resultant force is always the summation of all the forces. So this will be R subscript F, which is equal to the resultant force. So what we are saying is that what F1 and F2 can do, only RF can do it. Example, let's assume this is 10 Newton. This is 20 Newton. The resultant force will be equal to 10 plus 20, which is equal to 30 Newton. So it means what 10 Newton and 20 Newton acting in the same direction can do, only 30 Newton can do the same thing. Class, are you okay? Are you
Please come
okay?
again.
Yes.
So it means that what 10 Newton and 20 Newton, when they are acting in the same direction, can do, only 30 Newton can do it. And 30 Newton becomes the resultant force. Okay. All right. Now, so meaning if there are many, if we have many vector quantities acting in one direction, the resultant force is always equal to the summation of all of them. Okay, and the direction of the resultant force is the direction of the forces. And so Elizabeth, Eva, Mami Efua are asked to push a chair in one direction. They all exert individual forces on the chair. Okay, so the resultant force would be equal to Elizabeth's force Fe plus Eva's force Fe plus Erefua E. So the follow-up question is that what can be the direction of the resultant force? The direction of the resultant force would act in the direction of the forces. They are all moving in a certain direction. And so that will be the direction of F. Okay. Now, if I have before we go to opposite forces or vector quantities, if this is what I have, and we have F1, F2, F3 acting on the body, the resultant is equal to F1 plus F2 plus F3, meaning that the forces are in the same direction, right? Now, when forces are acting in the same direction, we say they are parallel to each other. F1 is parallel to F2. F2 is also parallel to F3. When forces are parallel, what is the angle between them? When vector quantities are parallel, what is the angle between them?
Zero
Yes.
degrees.
Good. So that is
Zero.
Thank
0
you.
degrees.
0. So when vector quantities are acting, okay, in that parallel manner, the angle between them is 0. If 0, then the resultant is obtained by summing up all the individual forces. The same body. This time I have two forces, one acting due is F1 and the other acting due west, F2. What will be the resultant force? R resultant of these two arrangements. By the way, the two forces are along one plane, meaning that this is along the x-axis. Okay, this is the x-axis. F1, F2 act along the x-axis. And so we conclude that the forces are acting along one plane, along the x-axis or the horizontal. If F2, F1 act in this manner, what is the angle between F1 and F2? What is the angle between F1 and F2?
Repeat the question again.
This is the diagram.
So please your question again.
F1 and F2 act along the x-axis. Let me redraw. What I mean by both of them acting along one plane. This is the mass or the body. This is the negative x, positive x. I can also draw to indicate positive y, negative x, y. Now these forces are acting along the x-axis. So F1 is here, F2 is here. Because all the two forces act along the x-axis. Mamiya. Or it's a mistake. Okay, because the two forces F1 and F2 act along the x-axis, we say that the forces act along one plane. Forces act along one plane. One plane. And that one plane is that they act along the x-axis. If it had been like this, if F1 is here, then F2 is also here. Still, because F1 and F2 act along the y-axis, they are acting along one plane. So this is what I mean by when forces act along one plane. Please, are we okay?
Yes, please.
All right. So my question is that F2 and F1 are
Yes, sir.
acting oppositely to each other. F2, F1 are acting oppositely to each other. Oppositely to each other. What is the angle between F1 and F2?
180 degrees.
108 degrees. Thank you. Thank you. So the concept is that when forces act oppositely to each other, the angle between them is 180. And when forces act parallel to each other, the angle between them is 0. All right. Now, how do we determine the resultant force here? If we have F1 and F2 acting in this manner, how do we determine the resultant? Yes. Idea sharing. Angel, are you there?
Yes, please.
Angel, how do we determine the resultant in a situation like this? Yes. Okay, Elinam, you want to eliminate Angel. Elinam, eliminate her. Pardon?
I'm attempting the question. I'm attempting the question. You subtract F1 from F2 or F2 from F1.
Why? Why must it be?
So, so please, you are trying to determine the resultant force. That's when both forces are applied in the opposite direction. What would happen? And apparently, the body would move in the direction of the greater force.
Exactly.
Though there would be some resistance.
Yeah, that's all that I want. So the condition is that if F2 is greater than F1, okay, the resultant force always acts in the direction of the larger force. So if F2 is greater than F1, then the resultant force will be F2 minus F1. And the direction of the resultant would be towards west, because F2 is acting this way in the direction of the west. Now, if it is F1 that is greater than F2, then the resultant would be F1 minus F2. And what will be the direction of the resultant force? Where? In this case, what will be the direction of the resultant force? We are saying that the resultant force always acts in the direction of the larger force. So when you identify the larger force, that will be the direction of the resultant force. So if F1 is greater than F2, what will be the direction of the resultant force? Elinam.
So it would move in the direction of F1.
Exactly. So let's give real application. Real application. The application of this is tug of war, which has changed to tug of peace. Whether peace or whatever, the initial name had to be war. So during tug of war, a number of people would pull the rope in one direction, and others will also pull in the opposite direction. Whoever wins is the one that applies the larger force. And you realize that those who win would always be pulling those, okay, who lose. So the resultant will act in the direction of the larger force. Then they will pull them along. That is what is happening here. So assuming if F2 is 30 Newton and F1 is 10 Newton, then the resultant R would be equal to F2 minus F1, because F2 is larger than F1. So we have 30 minus 10, which is equal to 20 Newton. Okay, so this is that single force whose effect, okay, that single force whose effect is equal to the combined effect of F2 and F1. And the direction of the resultant will be the direction of F2, due west. So the concept to note here is that when two forces are acting oppositely to each other, the angle between them is 180. And here the resultant force is equal to the difference between the forces. And the direction of the resultant force is the direction of the larger force. Please, are we okay?
Yes, please.
The girls, let me hear your voice. Are you okay?
Yes, please.
Yes, please. Yes,
Then
please.
let me create a problem for you. Or you don't want problems.
Yes, sir, you don't want problem.
I know. I know, don't worry. I have this. This is a body. We have these forces acting on the body. 3 Newton. This is F1. F2. 5 Newton. F3. 6 Newton. As against F4, which is 10 Newton. The forces are acting along one plane, meaning they are all acting along the x-axis. Determine the resultant force and the direction of the resultant force. Leonard, have you finished?
Yes, please.
What's your answer?
The resultant force was 14 Newton, and it was moving the direction. It was moving in the direction of the.
Leonard, come again. Leonard, come again. No. Look at it again. Yes.
The resultant force was 14 Newton, and it was moving the direction of F3.
Look at it again. Yes. Angel. Oh, okay, Peter. Oh, it's a mistake.
Please, it's 4 Newton.
The resultant is 4. How did you get that?
Yes. Sir, please, the forces acting on the right side, the positive side, you sum all of it, then you subtract it from the force acting on the negative side. That will be 4.
Okay. I'm coming. Let me pick this coin and Leonard, I think that is how you must approach it. You see, Once they are acting along one plane, you sum all the forces in one direction. So summation of all the forces to the right, you have 3 plus 5 plus 6.
Sir,
This is giving,
I didn't
hello,
see the F4. I didn't see the F4.
okay, all right. So this is 14 Newton. Okay, Josiah, I've noted. Okay, and this is a single force. So the resultant would be equal to 14 minus 10, giving us 4 Newton. So what will be the direction of the resultant? The direction of the resultant is always towards the larger force. So it will be due east. Please, are we okay?
Yes, please.
As for this part of vectors, simple. We'll get there. I'm modifying the same question by introducing F5, which is 3 Newton, and F6, which is 20. So we have F2 is 5, F3, 6, F6, 20. So this time around, we have F2, F3, then F6, which is 20 Newton. What is the resultant this time? The resultant force and then the direction of the resultant force this time around. So look at it when you finish to share with us. And that's Safo. Safo, are you there? Asian.
Yes,
Are you
please.
there? Okay. Yes. What is the resultant? Okay. Elinam.
So the resultant force is 27 Newton.
Is what?
27 Newton.
And the direction?
It's moving in the direction of F1, F2, and F3.
So this is due east, due west.
It's
So
moving due east.
Okay, let's see. Do we have any different view? Any different view from what Elinam shared with us? Oh
Yes, please.
Jacob, then reconnect it and let's see. If you have any different view, let me hear from you. Elinam again.
Sir.
I am taking the view.
The resultant is 13 Newton, due west.
All right, so let's see. So we have 13 as well. So let's see. You see, Angel, I'll angle you. Mommy, yeah. Mommy, yeah.
I think it's 21 newtons and it will be due east.
20, okay, so we have 13, 21. All right, so let's see. You see, this time around, the directions are mixed. So you must identify individual directions, okay, along one plane. If I look at our forces, summation
Sir.
of, hello,
I've got a different answer.
okay. If we look
I
at
had
direction of, hello, hold on, let's discuss it. If we look at direction of forces due east, we have F1 plus F2 plus F3 plus F5. They all act due east. So 3 plus 5 plus 6, okay, plus 3. This is giving us 8, 11, 17. Now, summation of forces due west. F west, F east. We have 20 plus 10. This is giving us 30 Newton. Therefore, the resultant would be the difference between them. But the larger one wins. So summation F west minus summation F east, which is 30 minus 17. And the answer will be 13 Newton due west. That's the resultant. So 13 people, clap for yourself. 20 something people, better luck next time, okay? Now, when two forces, and here we are limiting it to, we are looking at the two forces acting along two planes. This time around, this is what I have. All the earlier examples, the forces, okay, were acting along one plane. So we have F1, F2. F1 is due north. F2 is due east, meaning that the angle between them is 90. If you have a situation of this sort, how do you determine the result? If you have two vector quantities acting in this manner, how do we determine the resultant? Any idea? No idea. Okay. All right. This is how we go about a situation like this. You see, they are not acting along the same plane or axis for you to combine. One acts due north, and the other one acts due east. So in a situation like this, we look at we resolve the forces. So we resolve forces into a rectangular component. What do we mean by resolve the forces or vectors in a rectangular component? By looking at their direction, it doesn't make any sense. You can't tell where the two forces are going. Look, F1 going to the north, then F2 going to the east. Can you tell where the two forces are going? Where are they going? You can't tell. So you have to direct them so that their directions will follow a sense of order. Because as it is, there's no orderliness in their direction. You can't tell where they are going. So realign their directions so that they will follow a sense of orderliness. And how do we do it? We do that using equal vectors approach. So one, resolve direction of vectors. So they follow a sense of orderliness. And you could do that using equal vectors approach. Now, what is an equal vector? I'm going to draw a vector that is equal as F1 and equal as F2. When do we say vectors are equal? Vectors are equal, are said to be equal when they have same magnitude and direction and are parallel and are. So vectors are said to be equal when they have these qualities. They must have the same magnitude, direction, and the two vectors must be parallel, meaning irrespective of the location of two vectors, if they are equal, they must have these qualities. So a vector can be here. Another vector can also be here or far. So long as they have the same magnitude, the length from here to here must be the same from here to here. Now, if they have the same direction, due north, and these two vectors are parallel, I can say that they are equal. They are equal vectors. So A and B are equal vectors. They are equal because they have the same magnitude, direction, and these two are parallel irrespective of where they are. So to realign the direction of F1 and F2, this is what I must do. I'm going to create an equal vector of F1 and put on F2. But a vector has this point as the tail. This is the tail, and then the arrow indicates the head. So a vector has a head and a tail. Okay, or if I should draw it this way, this is the tail, the arrow indicates the direction. Then this point is the head. So I'm going to put the equal vector of F1 and put it on the head of F2. So what I'll do is that I'll bring the arrow to the middle, then draw a vector on the head of F2, which has the same magnitude, direction, and parallel to F1. So this is how I'm going to do it. The vector must have the same magnitude. So whatever I measure from here to this point, I'm going to measure the same thing. Now, because this is the equal component of this, I try to make it a bit different from F1. What is the direction of F1? Towards the north. So it must have the same direction. Same magnitude from here to here. And so I have from here to here. And this must be parallel to this. Once this one has the same characteristics as this, I can say that this is also F1. They are equal vectors. So I have created the equal component of F1 and have placed it on the head of F2. I'm going to do the same thing for F1 too. Create equal component of F2 and put on the head of F1. So measure the same magnitude from here to here, must be the same as this one. This is the clone or the image, so broken line. Same magnitude. Then I must have the same direction. And so I can also call this as F2. Now look at it. Look at the directions now. When you pick this, F1, look at the direction of F1. Look at the direction of F2 when you look at it from above. Then when you look at it from below, look at the direction of F2. Look at the direction of F1. Now, there is a sense of orderliness. So then I can say that, oh, okay, if F1 is moving in this direction and F2 follows it to this direction, then when I draw a vector from this point, okay, to this point, it will be equal to this and this, or this and that. So a vector drawn through the diagonal becomes the resultant vector. R. It's similar to, okay, you want to come here. Somebody would decide, let me move from here and then from here to this point. Or from here to here, then from here to here. Okay, then somebody can also that. What can be the shortest possible distance? Oh, move directly from here to here, and this becomes the resultant. But you could do that after resolving them, realigning the direction. So this becomes the resultant. And so from triangular law of vectors, from triangle law of vector addition, we can say that, okay, because we've aligned the direction, then R is equal to F1 plus F2. This is from triangle law of vectors. But vector addition is also commutative. So you can say that R is equal to F1 plus F2, or R is also equal to, when you pick it from here, F2 plus F1. It obeys the law of commutativity. Now note that you can only use triangle law of vector addition to find the resultant if it's a scaled drawing. So you can use this to find R if the diagram to you, given to you, is a scale drawing. And later I will explain what scale drawing means. If it is not scale drawing, then you must use formula. If it's not a scale drawing, then you must use a formula to calculate for the resultant. If diagram is not a scaled drawing, then use formula. And what is the formula here? This is not a scale drawing. I just use freehand to put certain things together. What is the formula? You see, because this is equal to this and they are parallel, then we can say that F1 is perpendicular to F2. Because F2 is parallel to F1, then we can say that F2 is also perpendicular to F1 here. And so whether we look at it from up or down, it creates something like a right angle triangle. F1, F2, and when you align their direction, you have this as the resultant, R. This is perpendicular to this. This is perpendicular to that. So you can determine this using Pythagoras theorem. So by using Pythagoras theorem, which is the formula, you can find the resultant. And what does the Pythagoras theorem say? Pythagoras theorem says that if you have a right angle triangle with opposite side A, adjacent B, hypotenuse C, the square of the hypotenuse, C squared, is all equal to the sum of the squares of the other two sides. So A squared plus B squared. This is Pythagoras theorem. Class, are you there? Are we there?
Yes, please.
Yes, please.
Good. So from what we have, we are going to use Pythagoras theorem to find the result, and because it's an unscaled drawing, so R squared must be equal to F1 squared plus F2 squared. Therefore, R would be equal to square root of F1 squared plus F2 squared. And what is the direction of the resultant? This is the resultant. This becomes the direction to the nearest force, which is this. So if I want to find the direction of the resultant force R, when I take the tangent of this angle, tan of theta, tangent is opposite over adjacent. The ratio of the opposite. Please, are you familiar with the trig ratios?
Yes,
Are
please.
you? Okay. So as we
No, please.
as we began vectors, I'll talk about the trig ratios as well. Okay. So if I want this direction, then I must, because I have F1, F2, I can take the tangent of it. So tan theta is F1 over F2. But if you have found R, you can take the cosine and then the sine. So if you take the sine of the angle, you have F1 over R. If you take the cosine of the angle, you also have F2 over R. And that will give you the direction of the resultant. Please, any question? Please, any question before we use that to solve a problem or for question?
Please come again.
With which one? Yeah, with which one?
So the tan theta.
The tan, if you take the tan theta, then you are looking for the direction of the resultant. Okay, I'm coming. A minute. What do I mean by direction? You see, look at where R is heading, pointing to. R is going up along the diagonal. So if I want its direction, okay, it is the angle it makes with one of the forces, the nearest one, the horizontal one. So this becomes the direction of it. So when I'm able to determine this angle, theta, I'm determining the direction of the resultant. And to do that, because you have F2, you have F1, you can use tangent. Okay, tangent to determine theta. What is tangent? It's a ratio of the opposite side of the right angle triangle to the adjacent. So tan theta is equal to, the opposite side is F1. The adjacent is F2. So tan theta is F1 over F2. If you have the hypotenuse, which is the resultant, you can also use sine and cosine. Okay. So you can use sine and cosine if you have the hypotenuse. And the hypotenuse of the right angle triangle is the longest side of it. Okay. So if you use sine of the angle, you have sine is opposite over hypotenuse. I think in our next video, I'll take you through Pythagoras theorem and then the trig ratio so that you can be able to apply this well. But if you want to use sine, then since sine is the opposite side, F1 divided by the longer side, which is the hypotenuse, it is F1 over R. If you want to use cosine, cos is adjacent adjacent over hypotenuse. And adjacent is the force F2. So cos theta is equal to F2 over R. And that will give you the direction of the resultant. So let's see how we can solve an example. Apply this in solving questions. So that we have two forces. A force is a vector quantity of magnitude two forces of magnitude 10 Newton and 20 Newton acts perpendicularly to one another. They act perpendicularly to one another. Or if it's not perpendicularly, we can use normally. So perpendicularly and normally indicates that the two forces or vector quantities are acting at an angle of 90 degrees to each other. So meaning they act along two planes. Either one is due north and the other one is due east. Or it can also be due west and due north. This can also create, okay, or this. But usually when they don't specify, we are always drawing it along the positive y and positive x. So the two forces, 10 Newton, the order doesn't matter. And then 20 Newton, they act in such a way that the angle between them is 90. Unless the question specifies that maybe 10 is along the north and then 20 is along the east. It is not specified. So all that we are interested in is to create two forces that are relating to each other in this manner. And the order doesn't matter. So determine the resultant. Okay. The question is that determine the resultant of the two forces. So what will be the result? Simply that's the meaning of the question. What will be the result? How do we do it? Looking at it, the directions are in this array. Okay. They don't create any sense of orderliness. So I must realign them. So I'll create equal vectors. I'll create F1 and put it on the head of F2. Vectors are equal when they have the same magnitude direction and both are parallel. So this is also 10 Newton. I can even decide to either draw the other one. Yasmin.
Please, if it's not drawn to scale, do you still redirect it like this?
Yes. Okay. As I said earlier, unless the question defines where the two forces are. Maybe 10 Newton acts due north, 20 Newton acts due east. Then there has been specifics. But here, there's no specifics. Okay.
Yes, please. Thank you.
And over here too, I'm just giving a sketch. They are not drawn to scale. So the moment I even draw for one, for the 10 Newton, I can see some orderliness. Look at the 20. The 20 Newton force is in this direction and then joins it by the 10 Newton. So I can predict the destination that, oh, okay, if this one acts here and then it's followed up by this, then when I draw a vector from the tail of 20 to the head of 10, it will give me the resultant. And the direction of the resultant will be towards this direction, because this is going here, this is going here. So it's like they are all coming to this point. So if I'm to be given the shortest distance, then I'll be asked to move from here to here. So this will be the arrow indicates the direction of the resultant. I remember in one of the classes, a student asked, why is it that the direction isn't coming down like this? That was the question, but it's going up. It's going up because if this is going here and this is also going here, assuming these are distances, and you are asked to indicate the direction of the shortest possible distance, then you must move from here to here. So certainly your direction must go up, not down. Please, are you okay? Are you okay?
Yes.
Okay, so if I even decide to add this, create the equal vector of the 20 Newton on this, it will even further explain it the more. But it will be the same thing. So look at the direction. Either you are going here and here, or here and here, and we'll get to the same point. So this is parallel to this, meaning this is perpendicular to the 20. So I can use Pythagoras theorem to determine my resultant R. So R squared will therefore be equal to 20 squared plus 10 squared. This is 400 plus 100, which is 500. Therefore, R would be equal to the square root of 500. And what's the square root of 500? What's the square root of 500?
Root.
Come
Root.
again.
22.36.
Again.
22.36.
So that's the resultant. So what these two can do when they are perpendicularly to each other, only this can do it. What is the direction? The direction is this. If I'm able to determine this angle, I have the direction. Let me call this angle alpha. Okay, so maybe if assuming that this is 30 degrees, then I can say the direction is 30 degrees from the east. So when I measure an angle of 30 degrees from the east, I follow the direction of this. If you measure anything less or more than this, it will take you to a different place. Assuming you have the direction to be 45 degrees from the east. Meaning, if this is 45, this is where you'll be moving to. Meanwhile, this is the direction. So determining this angle gives you the direction of the resultant. And since I have the opposite, I have the adjacent, I can take the tangent. If I take tan of alpha, tan alpha is equal to opposite 10 Newton over adjacent 20. And this is equal to half. How do I find the angle? When I take the tan inverse of this, alpha will be tan inverse of 0.5. This is on your calculator. On your calculator, you look for shift, then you press on tan. Then you input 0.5. Then you press on equal to. So you press on shift, then you look for tan, then input the value and equal to. Somebody is giving me what? Is that 20 what?
26.5.
So alpha is equal to 26.58. Meaning, if I want to follow the direction of the resultant, all that I do is that I measure from the east an angle of 26.58, which must be this. And 26.58 would give me where R is going. So when I follow this, it will take me to the destination of R. That is what it means.
Please,
Okay.
it's 26.586.
Okay. Then it means the 26.58 will not take me there. So that is how to resolve vectors when they are acting perpendicularly to one another. We've looked at when they are in one direction, when they are in opposite direction, and when they are perpendicularly. I'll send you good questions on this. And then the other ones we just have gone through. Then tomorrow, I'm hoping power doesn't fail us so that we make amends with our lost time. Okay. There we can look at when vectors are acting at any other angle, other than 0. We've done 0, parallel. We've done 180 oppositely, and we've just done perpendicularly 90. At any other angle, how do we determine the resultant and then the direction? Then we move on and on. Okay. I think our time is up. If you have any question, quickly ask. If you have any question. If you don't have any question, then this is where I draw the curtains on today's meeting. Thanks so much for your time and then your everything. Okay. We are sure to have another wonderful session. Possibly tomorrow. Until then, please, may the good Lord be with you and take care of yourselves. Bye-bye.
Bye.
May the Lord
Bye.
Okay.
Have a nice day.
Have a good
All right.
day.
Same to you. All right. Bye-bye.